Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to the class. Today we'll be learning about linear graphs, mathematics for class 8, chapter 1, practice now 2, and exercise 1b. Let's start our lecture. First of all, a message from HiveWorks for IT solutions. Please contact Mr. Imran Yunus Khan, Senior Marketing Manager, contact number 0309 666 2288. Website www.hive-works.com. Now coming out to the practice now 2, chapter 1. As we have studied earlier, that in this problem we have to find the gradient of different lines. First, we will be considering the line AB now. Just consider this line AB. 0 or OA. Line OA having the point O coordinates at x-axis 0, coordinates at y-axis 0. Point A coordinates at x-axis 10, coordinates at y-axis 9. Now it means that 10, 9 means that on x-axis this point lies at point 10, and 9 means that this point on y-axis lies at point 9. So we have to find the gradient of line OA. Then second line, line AB, straight line. Now in line OA, start point or initial point was point O with coordinates 0, 0. Final point, point A, 10 and 9. In line AB, the coordinates were for the point A, initial point 10 and 9, for the final point, that is point B, 30 and 9. So 30 means that on x-axis this point lies at 30, and on y-axis this point lies at 9. Now for the line BC, this is the initial point and C is the final point. At point B the coordinates were 30 and 9. So x-axis 30, y-axis 9. At point C, x-axis 35 and y-axis at point 5. Similarly for point D, 55 and 5. 55 on x-axis, this is x-axis, this is run axis, and this is rise axis. Y-axis, rise axis. So 0.5 at y-axis. So this line terminates or culminates at point E, 62 and 0. 62 on x-axis and 0 on y-axis. So this is the point E. We have to find the gradient of line OA. So first of all, we will be finding the gradient of line OA. This is gradient of line OA, rise divided by run. It means that final position on y-axis 9 and initial position on y-axis 0. Then 10 minus 0, 10. Final position on x-axis 10 and final position on initial position on x-axis 0. So 9 minus 0 is 9. 10 minus 0 is 10. So 9 divided by 10 is 0.9. So positive, it means that this line moves from left to right upward. Slope is 0.9. The gradient of line AB, rise divided by run. This is line AB. In y-axis, final position 9, initial position 9, x-axis final position 30 and initial position 10. So rise divided by run is equal to gradient. So 9 minus 9 is 0. So this is having no slope. Straight line. Line BC. Gradient of line BC, rise divided by run. So C is at point 35 and 5. And B is 30 and 9. So final position on y-axis is 5. Initial position on y-axis is 9. Final position on y-axis 5. Initial position on y-axis 9. Final position on x-axis 35. Initial position on x-axis 30. Final position on x-axis 35. Initial position on x-axis is 30. So 5 minus 9 is minus 4. 35 minus 30 is 5. So answer is minus 0.8. So this line BC, its downward slope is like this. Direction of arrow is showing the slope of the line. Now coming to the line CD, the straight line. Rise divided by run, 5 minus 5 divided by 55 minus 35. So 5 minus 5 is 0. Now the gradient of line DE. E is having coordinates 62 and 0. D is 55 and 5. So rise divided by run, 0 of y-axis final position minus 5 divided by 62 of x-axis final position minus 55 x-axis initial position. So answer is minus 5 divided by 7 is minus 0.72. Slope is minus 0.72. It's downward slope. Moving to exercise 1B, question number 1. This is x-axis, time in hours, y-axis, distance covered. Now, coordinates of point O, 1000, 1000 hours, 1000 and 0. At x-axis 1000, y-axis 0, line OA. And this is the final position for line OA, that is 1100 hours and 50. So it means that this is initial position for line OA, this is final position. This is line AB, initial position, final position. And now coming over to line BC. This is initial position, this is final position. Let's start. Gradient of line OA is rise divided by run. So 50 of y-axis final position minus 0 y-axis initial position. 50 minus 0 is 50. Final position of x-axis is 1100 minus initial position of x-axis 1000. 1100 minus 1100. 50 divided by 100 is 0.5. So this gradient is 0.5 meters. Average speed is distance covered divided by time taken. So distance covered is on y-axis. So this was 0 and this was 50. So distance covered 50 kilometers. In time, 1 hour. 1100 hour minus 1000 hour is 1 hour. So 50 divided by 1 is 50 kilometer per hour. So gradient of line AB. This is line AB. Gradient of line AB is rise divided by run. So but the coordinates of y-axis, final position 50, initial position 50, 50 minus 50 is 0. So this is straight line. Gradient of line BC. Gradient of line BC, rise divided by run. Final position on y-axis 80, initial position 50, final position on the x-axis is 1200 hour, initial position on x-axis is 1130. So 80 minus 50, y-axis, final position minus initial position, 1200 minus 1130, that is final position on x-axis, and initial position on x-axis 30 divided by 30 is 1. This slope is 1. Average speed is 30 kilometers divided by 0.5. Because on x-axis initial position 1130 hours, final position 1200 hours. So it is 0.5 hour or 30 minutes. So for taking the average speed, we have divided 30 divided by 0.5 is 60 kilometer per hour. This is the average speed of the traveler. Now moving to Question number 2, exercise 1b. Here we have initial point O, 600 and 0. 600 on x-axis and 0 on y-axis. Point A, 100, 840. Now 800 on x-axis, this is x-axis, and 40 on y-axis. Now, distance of the post office from a traveler house is OA, 40 kilometers. So, distance is on y-axis, this is 0, this is 40. He stayed at post office AB. He stayed at line AB for 1 hour. That is, from 900 hour, he departed. He arrived at 800 hours. He departed at 900 hours. So, this is a difference of 1 hour. He stayed at Hawker Center CD for 30 minutes. Arrival at 1030 hours. Departure 1100 hours. Gradient of line AB and CD is 0. Line AB, straight line, no slope. Line CD, straight line, no slope. Now we have to find the gradient of line OA. Gradient of line OA, we have to find the initial position on y-axis is 0, final position on y-axis 40, final position on y-axis 40 minus initial position on y-axis 0, final position on x-axis 800, initial position on x-axis 600, final position on x-axis 800 minus initial position on x-axis is 600. So 40 minus 0 is 40, 800 minus 600 is 200. So this gradient is 0.2 meters. Average speed, distance covered divided by time. So he covered the distance of 40 kilometers in 2 hours. If you do, subtract 600 from 800, so it's 2 hours. This is the time in hours. So 40 divided by 2, it's 20 kilometers per hour, because 40 kilometer distance covered, time taken 2 hours. So 40 kilometer divided by 2 hours is 20 kilometers per hour. So his average speed was 20 kilometer per hour. Now, gradient of line BC. Line BC. This is B. Initial position on x-axis 900, final position on x-axis 1030, initial position on y-axis 40, final position on y-axis 20. So line BC, rise divided run is gradient. So final position on y-axis 20, initial position on y-axis 40, divided by final position on y-axis 1030, initial position on x-axis is 900. So 20 minus 40 is minus 20 divided by 130. So its gradient is minus 0.154. It is evident that the line BC is sloping downwards, so its gradient is negative. Now the gradient of line DE, this is point D, this is point E. Point E is having coordinates 1200 and 0, D 1120. It means that on y-axis final position 0, this is y-axis, this is 0, and initial position on y-axis was 20. Now final position on x-axis 1200, initial position on x-axis 1100. So the gradient is the rise divided by run. So final position on y-axis is 0 minus initial position on y-axis 20. Final position on y-axis 0 and initial position on y-axis 20 divided by final position on x-axis 1200 and initial position on x-axis 1100. So its answer is minus 20 divided by 100 is minus 0.2 meters. So gradient is 0.2. Average speed is 20 kilometer divided by 1 hour is 20 kilometer per hour. Thank you.